Hey YouTube, welcome back. Today we will talk today our 12th video, 11th video from our series design a rate limiter. When our series that we give a system design, we have a system design question interview with design a rate limiter, but we go into details and describe why we choose like this solution and these solutions. And yeah, so basically today we will talk about we put the detailed design of our system. And basically let's just basically we are into the deep dive. Maybe we have one video. I guess we have two videos or like three videos. Yeah, I guess this video and two more videos, so I guess we have lost three videos basically. And if you didn't watch the previous videos before, I highly recommend that you should watch them. Anyway, if you watch the previous video but you want to make sure that you don't remember what we are going through, so I will just make a small introduction and review, so you make sure that you do not left out. And yeah, so let's start. Basically, we have a design a rate limiter. It's a question of system design interview, and as we said all the time, that the questions in the system design interviews are all the time too vague. So like design a rate limiter, design Facebook, design YouTube, so then Twitter, and especially the interview doesn't give us a lot of clarification on what we should really build, because there is tons of things that we could build. So basically our job as an interviewee is to make sure that we ask the questions to make sure that we understand the problem and actually know the requirements, and after that we propose the high level design, get deep in specific components. After that, wrap everything up. And basically we have this formula that help us to create a plan to make sure that we are doing things right. The first thing that we start on with understanding the problem. So basically, if in when we want to understand the problem, we want to ask from like 5 to 10 questions each for each interview. Depends on how vague and how complex the question is. So basically, what a specific type of so basically we ask about here 5 questions. So basically, what specific type needs to be limited. So basically, we ask what type of rate limiting we are creating. It's an API focused service. Okay, so does the rate limiter work with IP address or the ID user? Basically, we want to know, because we will work with the functional requirements. What is the scale of the system? Are we talking about the distributed system? Yes. Should we rate limiter respond the user that been blocked? Yes, also. Or there any performance or latency requirements are needed? And it's quite important that maybe when we ask the question, we don't have all the functional requirements and non-functional requirements that the interviewer wants. So after we get these questions and we put the functional requirements and non-functional requirements, we ask the interviewer again, are everything okay? Are everything right? Do I missing anything? So to make sure that we are not we and the interviewer in the same page. Basically, the key feature in this system design interview is that we communicate and we create a plan. This is the two most important things that a lot of developers, including me, actually sucked at. I made a lot of problems that I wasn't good at communications, and other times I wasn't good at creating a plan, and I just start rambling and waste time. Yeah, so basically you just make sure put these two things in mind. So basically we have functional requirements. Basically the rate limiter must be able to limit the rate of request for specific type of request. The rate limiter must respond to user when the limit is exceeded. The rate limiter must not be able to track the rate in real time. It must be able to track the rate in real time. Basically, the non-functional requirements is the rate limiter must be high available. The rate limiter should have low latency. Which should has high fault tolerance. And basically, the high fault tolerance. I guess that we should have these two things. I guess, yeah. This is, I guess, this way more cleaner. It's a high fault tolerance, and we should, but also the lead. No. Let's go back. We should have availability because we will use a Redis database. So yeah, that should have availability. And the rate limiter should have high fault tolerance. Basically, when the application went down, basically the application the server will not be affected by that. Use as little memory as possible, and it's a distributed system. And basically, we went to the second thing. We finished that, we understand the problem and we know what we're building. The second thing is that we should propose a high level design. And in the proposed high level design, we have the two questions basically to ask. It's one, where we should the boot limiter, and the second, it's the where should we what specific type of algorithms that we should, and basically the third question is a three question, not the two. Where should we store the counter and the tracker? So basically, the first one, where should we put the rate limiter? We have two solutions: is to put it on the client, and the other was to put it on the server. And we said that putting it on the client, we will not have much control on it. So basically, it's a better solution to put it on the server. And putting the server, we have also two solutions. When the put in the servers, we have only two solutions. Is that if we are using a microservice architecture, we put the rate limiter in the API gateway. Otherwise, if our application doesn't support the microservices architecture, maybe the technology that we are using can't support that, so we will put the rate limiter with the API services. And we talked about the algorithms, that we have 5 algorithms: the token bucket, the leaking bucket, the fixed window bucket, and the slide window log, and the sliding window counter. And we discussed them in the previous video, so I will not discuss any one of them. And after that, we went to, okay, we know where should we put it, and also we know where should we put the rate limiter, and we know the algorithm that we could use. And basically, when you are in system design interview, when you're using algorithm, just make sure that you see the pros and cons on everyone, and maybe you and the interviewer will talk specific type of algorithms. And basically, we have the last question, is that where should we put the counter and how we should handle the actual counter. So basically, it's that we have two solutions to store the counter. It's that one, to store it in a table, like SQL database, or like disk database basically. So the problem with that, it will be quite high latency. So basically, we use a Redis database. That Redis is in-memory database. So basically, it's have a super low latency, and we will use the increment that increases the store by 1 and expires the set, and we have expires that set timeout for the counter. And basically, that was it. And we had two things that we had. We started last video, in our first video, on talking about the deep dive basically. And the deep dive that we have in the last video answered two questions: is how are the rate limiter rules created, and how and where are the rules stored basically, and how to handle the requests that are limited. So basically, we said about we create the rules. Is basically this is script. There is a lot of open source solutions that you can look at them. Like for this script, that this one say that each user, the client, is allowed to make not allowed to make more than 5 logins per minute. And for this one, it say that basically the marketing, basically we have a maximum of 5 marketing messages per day, and we store this one into like a script. And yeah, we store it in the script, and that's it basically. And we have what we should give as a response to the user. Basically, we'll give the user, in case of late limiting, we'll give the user 29 basically. That means too many requests. It's a response 428. That means too many requests. And actually, we'll give him some information in the headers basically about the X remaining and also the limit, and also the try after. And today we'll start to get we should put the detailed design. So basically, we have this design that we actually have right now. So let's add some details to it. So basically, we had right now, I guess that you understand everything. So basically, let's just put this one here with the database, because I guess it belongs to the database. So basically, the rate limit, let's say that we are working with the rate limiting right now. So basically, the rate limit has what I'm going to say. I forgot. Okay, anyway, so basically that we are talking about whether the rate limit is connected with the radius. Let's say that the rate limiting has rate limited, because we didn't talk about that. So basically let's just what is this? Ah, no, I want it to be white, and I want it to be thick. Let's just, how to make this one thick? Yeah, this is okay. It's not bad. So basically, it will be if it's rate limited, we have two options. However, let me just, no, I want just like that, and no, I want to make the okay, no, just make it like that. Okay, so basically if we have I want to add a text, it will be I guess they have a problem with their what is this? No, I guess I'm adding text. I guess that if we have a rate limiter, it will be, I would say 428. It is too many requests, and just to give this so yeah, let's just, and basically we have this one, and basically we has two options. Is that we could just create a one here. No, I want two solutions. I want two arrows basically. So I want to just, no, I want one like that, and it will be this one, and add another one here. Yeah, it will be like that. Okay, so basically we have two solutions. One is to request is dropped. So basically we have option one, the request will be dropped. Let us add the shape, make it white and quite thick and quite bigger, and it will be, the request will be dropped. And yeah. Oh, and the other solution that I'm going to put here, it will be, the request will be queued. Basically we can put message if we have a message queue. Basically, let's say that we have an order, we can just drop the order. We have the request is pretty important, so we just put in message queue, and we will process in afterwards. And I guess that we got most of the stuff, that we have our API servers, that we continue it with a success. However, I guess that we should store the rules in disk. We store them in a script, but we should put script in some sort of disk. So basically we put our rules here, and let's just increment this one, and I guess that these rules should be served from like workers, and yeah, let's just talk about this one. It should be, first of all, I want to be like that, and I want it to be opposite, and I want it to be this one. And also let's make it thick. So yeah, and the workers will fetch the rules. Let's just take this one and put here, and just like that, and they will store the rules in the cache. It's like they store it in a cache, and let's just, they will store the rules in the cache, and I guess the cache will send the rules back to the rate limiter. So basically, okay, let's just talk about this. What is this actually? Okay, so let's just talk about this design. So basically we start from, okay, let's just, I guess it's not easy to read like that, so let's just copy this one and put it, okay, let's just put quite, just, no, put here, okay, and this is the old one, and let's just take this one and just try to make it okay, we can do this one with this one. Okay, we can just put these things here, and this one, yeah, and we could delete this and just to try to make, yeah, I guess this one, it will be much better. And if I just put the rules like that, okay, I guess this one is maybe better. So basically, we have the rules, or basically the rules are stored in the disk. Workers basically frequently pull the rules from the disk, and basically they are stored in the cache. And basically when the client sends a request to the server, the request is sent to the rate limiter first. Basically rate limiter middleware loads actually rules from the cache, and actually it fetches the counter and from the Redis database, and also it and last request timestamp for Redis cache also, basically based on the response. The rate limiter decided to, if the request is not rate limited, it forwarded to the API successfully. If the request is rate limited, the rate limiter returns 429, and basically many requests, and basically that's it. And I guess that we that's it for the detailed design. And basically we could talk about how we will handle, I guess that if we make this thing is quite smaller, yeah, just like that, and also the workers just smaller, I guess it will be better because it just look huge. Just put the rules here, and also smaller, and yeah, I guess this one is better, I guess. So I guess that's it for the details design, and I guess the next video we'll talk about how we will handle the race condition, and maybe after that we'll talk about how we will handle the synchronization issue with basically with the distributed systems. And I guess that's it for today's video, and yeah, see you in future videos.